right, we are continuing to graph f of x equals ax squared plus c. This is the second video, so we are on example 4. All right, modeling real life. The function f of t equals 16t squared represents the distance in feet a dropped object falls in t seconds. The function g of t equals s sub 0 represents the initial height in feet of the object. Find and interpret h of t equals negative f of t plus g of t. B part says you drop an egg from a height of 64 feet. After how many seconds does the egg hit the ground? So you can see here's the building, 64 feet. Here's the person dropping the object here, or dropping the egg. All right, then C part says suppose the initial height changes by k feet. How will this affect part B? All right, so let's just look at one part at a time. So A part says find and interpret h of t equals negative f of t plus g of t. So all we have to do is take and plug in what we are given. So we have h of t equals, and then we're going to do negative f of t. So negative 16t squared. And then it says plus g of t. G of t is just s sub 0. So we're going to say plus s sub 0. So all we did to get h of t was combined, well, we had to do negative 16t squared and then add that to g of t, which is s sub 0. So it says to find and interpret that. All right, so we know the function h of t equals this, and we know that it represents the height in feet of a falling object t seconds after it's dropped from the initial height of s sub 0, and that's in feet because it's given in feet right here, and it says in feet right here. All right, so that means we know that the initial height is 64 feet, so now we can plug in the initial height for s sub 0. So let's take and say h of t equals negative 16t squared plus, and we're going to put the initial height of 64 feet because that's how far off the ground. You can see the person hanging out the window here getting ready to drop the egg. All right, now that we have the function, what do we want to do with that? All right, so we know that the initial height is 64 feet, and we're trying to figure out how many seconds it's going to take for that egg to hit the ground. All right, so we can take and we can substitute some values in. So let's make a table. So let's say t represents time. So let's say t equals time. And then we're solving for h of t, which most cases would be our x and our y. So this is like x and this is like y. So this is independent, this is dependent. So we can choose any amount of time we want. Time's not going to be negative, so let's start with 0. 1 second, 2 seconds, 3 seconds, etc. All right, so after how many seconds does the egg take to hit the ground? Well, we know when h of t equals 0, we know the egg's going to hit the ground, right? So let's see if we can figure that out using a table of values. 0 times anything is 0 plus 64. So we know 0, 64 was the initial height. 1 squared is 1. Negative 16 times 1 is negative 16. And then add that to 64. And you get 48. 2 seconds. So 2 squared is 4. 4 times negative 16 is negative 64. Negative 64 plus 64 is 0. So we don't even have to go to 3 seconds. We know that after 2 seconds, the egg is going to hit the ground. All right, let's go ahead and look at that graphically and see what that looks like. All right. So let's go to y equals. We're going to clear this equation out, and we're going to put negative 16 t is the same as x, so we're just going to do x squared, that's just our variable, and then plus 64. And if we hit graph, all right, we can't see the top because it doesn't go up 64 feet. So let's go to y maximum, let's say 65 feet, because that's higher than what we need. Graph, now it's going to go up and show us, again, t represents time, so we don't need anything except the first quadrant. So from here down, you can see that that does hit the ground after 2 seconds. You also can do second graph. Go to your table of values and you can see at 2, 0 is a point on the graph. So we can conclude that after 2 seconds, t equals 2. That means after 2 seconds, the egg will hit the ground. All right, so this is A part. B part. All right, now we have one more to look at. All right, C part says, suppose the initial height changes by k feet. How is this going to affect part B? All right, so the initial height changes by k feet. So remember, we're looking at ax squared plus c. And in this case, they're talking about k is kind of like your c value. So just a quick recap. So we've been looking at y equals ax squared plus c, but in some text you'll see that y equals f of x plus k, and we use h and k for a vertex in a lot of cases, so k is the vertical translation. So even though this says k, we're still thinking of it kind of like the same thing here, where it's just a vertical translation. So what is it going to do to the graph? So we know that the initial height changes by k. If it goes up higher, if the initial height goes higher, it's going to take longer to hit the ground. So if k is greater than 0, then it's going to be a few seconds, or it's going to be a little bit more time hitting the ground. If k is less than 0, that means it's going to move down closer to the ground when you drop the egg. So the egg would take less than 2 seconds to hit the ground. So basically understanding what this value does can tell you what it's going to do to affect the time. So the further you get away from the ground, the longer it's going to take the egg to hit the ground. The closer you move to the ground, the less time it'll take for the egg to hit the ground. So that's why when k goes positive, it goes up, you're further away from the ground. If it's negative k, if you're moving down, you're closer to the ground. All right, I hope I explained that well. If you have any questions, please let me know.